Hello everyone and welcome to today's session of this awesome event, the SCOM Workshop Week. My name is Stoyan and I have the honor of being your presenter. Today we are going to talk about SCOM Management Group design, database tuning and general SCOM optimizations. Before we dive into the session, allow me to present myself. I'm a senior principal consultant at the Swiss consulting company PON IT Consulting. I'm a 4-time MVP for cloud and data center management. My focus lies on private and hybrid cloud management, as well as Microsoft Azure and Active Directory. I'm a Microsoft System Center enthusiast and also a father of two. About today's sessions, everyone who deals with System Center Operations Manager on a daily basis knows the importance of having a management group that is highly available, but also has sufficient performance. Both factors have strong dependency on the management group architecture, but mostly on how the SQL backend is designed and configured. The session today will focus on designing a high performance and high available SCOM management group, and we will review some great tips and tricks for optimizing the SCOM's backend and the general infrastructure. The key takeaways from today's sessions: we would like to learn how to plan a management group for capacity and performance. We would like also to learn which configuration options directly impact the performance of the SCOM management group and how exactly to configure them. We would like to learn which workflow optimizations can be made in order to further boost the performance of your SCOM. And of course, we will review some best practices and recommendations. The session today will last about 20 minutes and will be organized in 3 blocks. So each block will have its own exercise. The first block being the management group design and key principles. The second, SQL backend configurations and best practices. And the third block we will cover application level optimizations for SCOM. What are the prerequisites? What do you need to have for this session? It will be great if you have a test or non-production environment where you can also play with all the stuff. It will be also really great if you have a SQL database instance with the possibility of making some configurations, or at least look at the settings there. And of course, this will require administrative permissions, not only on the SQL servers, but also on your management servers. And last but not least, we will need the Operations Manager Sizing Helper tool in order to size the databases of the management group we will design later. So let's jump right to the first block, management group design. Before we do our own design of a SCOM management group, according to some prerequisites, let's see what are the key influencing factors. The first factor has actually a huge impact on the number of management and gateway servers, and this factor is what is the required level of high availability. The second one is actually the type of the monitored workloads. So the different types of monitored workloads have also different requirements. The special thing about monitoring Linux, for example, or network devices or URLs is that they all need a resource pool to talk to. And of course, for these workloads, the workflows are run not on the agents themselves, but on the management servers or gateways, which actually costs performance. The number of monitored instances for each workload type is also a very important thing to consider, because of course this plays a key role on how many servers you need to plan for and also their hardware capacity. Last but not least, the size and the structure of the monitored environment is very, very important. So how many locations does the company have? Whether there are trust boundaries defined, so whether there are trust relationships between the domains, whether it's one domain or more domains, how the network is exactly segmented. This also is very important for the placement of the servers. And before going through a demo walkthrough for the design, let's see the key design principles we would like to apply today. The first will be always calculate the number of agents which are reporting to a single management or gateway server. So calculating the required number of agents will also define the number of management and gateway servers you need to use. And also we will define how those management or gateway servers are sized. What's important here to say is if you have agents which are reporting to a gateway server, this gateway server reports to a management server, and you need to take that into consideration. Very important article, guys, and I would like you to open this when you are doing your assignment or the first exercise. This will help you or be the main source of information when doing your design. The second principle we would like to discuss is actually you need to plan and size your resource pools carefully. So resource pools offer high availability for workload types like Linux or network devices, and they apply a logic similar to a clustering majority node set. So at a minimum, there must be 3 members in a resource pool to maintain a quorum, which must be more than 50% of the quorum voting members in a pool to maintain availability of the pool. If you only have 2 members of the pool and one is unavailable, you have lost the quorum. So this has to be taken into consideration when doing the planning on a later stage. And this article will cover this in detail. So if you have some questions or would like to learn more about resource pools, please go to this link and take this into account. So last but not least, we said that how the IT of the company is organized plays also an important role. If you have centralized IT, most probably would like to have your management group in the central location. But if your IT is spread amongst many offices, then a connected management group design most probably won't be a bad idea. So this would mean you have multiple management groups and they are connected. Of course, the network segmentation and network locations of the company are very important and need to be considered when designing your management group. More information about this you will find here. So let's jump into the first demo we will do today. This is, let's say, a walkthrough or how I would do a design of management group having some requirements. And then with the first exercise, I'm going to give you a task to you so that you can do your own design and also your own calculations. So we have a headquarter here. This is an Active Directory domain with around 2,000 Windows agents which need to be monitored. We have a centralized IT and we don't require application performance monitoring. We will see later how application performance monitoring relates to the database sizes. But now let's see, we have also Office 1, which has its own domain and it has a trust to the headquarter. In this Office 1 location, we have around 1,800 agents. We don't require application performance monitoring here. We have also 300 Linux agents. What is important to say is that the requirement here is high availability. So we need to consider this when doing the sizing. As already mentioned, this location has a trust, Active Directory trust, so Kerberos would be possible here and we won't have to deal with certificates. Unlike Office 2, where we have it's our own domain, but we have no trust to the headquarters. Here we have around 200 Windows agents. We don't require high availability for them, but we require application performance monitoring for hundreds of them. Let's see how we can design a SCOM management group having all those requirements. The first thing we will need are the databases. I will place them in the headquarters because this is our central location. We have only one management group we need to design because we have a central location where we will place this management group. For the SCOM databases, I will use SQL Server Always On for making them highly available. I would also install a reporting server to cover the reporting requirements, and then I'm going to go to Office 2 and do the calculations there. So Office 2 does not require high availability for the monitored Windows agents. So I'm going to place only one gateway server there, not two. And what I also need here is a certificate. The certificate is actually needed because we don't have a trust, we don't have Kerberos authentication, so this gateway needs to talk to the management server in the central location over the certificate. Let's see now Office 1, sorry. Here we will place two gateway servers which will cover those 1800 Windows agents. And we will also place 3 gateway servers in a resource pool here, which should cover around 300 Linux agents. What you will notice here is that we have 3 of them and not 2. This is very important to notice because those gateways organized in a resource pool need to be 3 so that we have a resource pool high availability. This is the case because we don't have the so-called observer here, or let's say an instance which will decide whether our resource pool is available or not. So this observer has to be on a gateway. Because of this, placing 3 gateways here, we will ensure high availability for those 300 Linux agents. If we have only 2 gateways, we won't have a default observer, and this will mean that our resource pool is not highly available. Those 3 gateways, you will also notice the certificates. Those are not the standard certificates used for authentication. Those certificates are actually cross-platform certificates used for the communication between the gateways and the Linux systems. Next, we will see what servers we are going to place in the central location. Those 2 management servers will cover not only the 2000 Windows agents in the central location, but they will also cover those additional 200 Windows agents which are in the Office 2. You should not forget that you always need to consider the number of agents which are monitored by gateways when planning the capacity for your management servers. The same is actually the case with those 2 gateways which are covering those 1800 Windows agents. I cannot actually use the same management servers in the central location for those 2 gateways because they're also already pretty loaded. So for those 2 gateways and for those Windows agents in the Office 1 location, I have planned for additional 2 management servers. And we have already mentioned we require high availability, so we have 2 management servers which will talk to those gateways. And of course, the same principle applies for the gateways which are covering the Linux servers. So they also need a management server to talk to, and they cannot talk to those 2 management servers because they are loaded. They cannot talk to those 2 management servers because those 2 management servers are dedicated for the gateways in the Office 1 location. So we will install additional 2 management servers in the central location to cover only the communication from those 3 gateways. And this is my short walkthrough. So you have to do exactly the same, but for another environment I have prepared for you. So before going to this, let us do a summary of the components we will need, and that would be also required from you guys. Please note or write down the number of servers or components which you have used for your solution. This is mine. So first I have 6 management servers. All of them are, of course, in the headquarter. I have 6 gateway servers, 5 in Office 1 and 1 in Office 2. I have 1 resource pool consisting of those 3 gateways in Office 1, and I have 3 cross-platform certificates for the gateways. I have 3 standard certificates, 2 on the management servers and 1 on the gateway in the Office 2. This is so that they can talk to each other. And I have 2 SQL nodes with 2 SQL instances and 2 SQL always on availability groups. I have 1 reporting server. I have as many as required consoles. I can do them highly available by configuring Microsoft Network load balancing if this is required, of course. And I have my web consoles. So those are the components I have used in this particular demo. And let's see what also needs to be done here. This is the hardware sizing part. For the hardware sizing, meaning the resources of your management and gateway servers, you need to turn to this article. This is an MS Docs article which will cover or help you size your components. And also what we need to consider is sizing the operational database and also the data warehouse. Here you will see that we do the sizing with additional number of agents. Like for example, I have 5,000 agents, but I plan for additional 1,000 agents in case my environment grows. So I have planned for growth and scalability. I need to consider application performance monitoring when doing the operational database and data warehouse sizing. And also I need to consider the retention period. So how long the data will be present in the databases before deleted. So for the operational database, I have lowered the retention period from the standard 7 days to 5 days. And for the data warehouse, I have lowered it to 180 days to reduce the size of the database. But very important notice here is this is a business requirement. So if your company says, I need to keep the data for a year, then you need to plan it accordingly. And short info about how I have sized my database. I have used the sizing helper tool to do this. And you see a screenshot from my sizing. I have used the 5-day retention for the operational database. You see the number of server computers. I don't have any network devices, but I do have some amount of application performance monitor enabled computers. And this leads us to a database which in its end size will be around 128 gigabytes of data, and this is with the required 50% buffer for this database. Let's see how the data warehouse looks like. With a retention period of 180 days, we have about 2 terabytes of data, and here, unlike the operational database where you need or you have to configure this number so that your database does not auto-grow, with the data warehouse, you can start with 1 terabyte and let the database auto-grow. So now to the exercise. You need to design a highly available SCOM management group and also size its databases. You have around 15 minutes for this, and here is what you need to write down or to calculate. So number of management servers, gateways, resource pools and where they are placed, number of members in each resource pool, number and type of the certificates which are required, and sizes of both database. And this is how your assignment looks like. You have a headquarter. It's a domain with around 2000 Windows agents and around 900 Linux agents. No requirement for application performance monitoring, but requirement for high availability. We have Office 1, no trust to the headquarters, its own Active Directory domain, around 800 Windows agents, and high availability is not required here. We have another office, which again has no trust to the headquarters, and we have around 120 network devices here with the requirement of highly available monitoring. And this is your Office 3, its own Active Directory domain, again no trust to the headquarters, around 200 Windows agents as well as 200 Linux agents, and a requirement for high availability. So guys, you have now 15 minutes to complete this task. I will let the slide here for those 15 minutes so that you can plan this accordingly. Please open the article for the capacity limits of SCOM, where you can really see the table with all the data and really calculate all the numbers. And we will see or talk in 15 minutes again. Thank you. Hi again, everyone. 15 minutes are up. Let's shortly see how a possible design here would look like before jumping to the next block and the next exercise. So I have planned here for one gateway because we don't require high availability in the Office 1. I have planned for one resource pool consisting of 3 gateway servers so that the resource pool is highly available in the Office 2 to cover the network devices, and I have also planned for one resource pool in the Office 3 location, and this resource pool or the servers from it will cover not only the Linux agents but also the Windows agents in the Office 3 location. In the headquarters, I have planned for a resource pool consisting of 2 management servers, and of course, I have planned additional management servers to cover the communication from the 3 offices. So those 2 management servers should be sufficient to cover all the agents from the 3 offices because the number of the agents is pretty low. But of course, you can increase the capacity of this and add additional management servers to those 2 management servers. So if your solution looks similar to this, then good job. And I hope you also have sized the databases. We won't cover this because it takes a certain amount of time. And now we are going to jump to the session block 2 and cover some SQL backend configurations and best practices. What I would like to mention here is, or encourage you to take a look at the recordings from the SCOMathon that took place in June. And there I had a session, a pretty long session about optimizing the backend for SCOM. Take a look at it, download it, and you'll find really great advices there. We will slightly touch some of those here, the most important ones, and I will also walk you through configuring those settings. Let's shortly see what are the optimizations we can do and also the best practices. The first part relates to the SQL Server itself, and it's recommended to have a high performance power plan on your SQL Server, but also on your management servers. And of course, if you run your SQL Server on a VM, then having a directly attached storage is really a good idea and is also a recommendation from Microsoft. So the most important part, in my opinion, would be the SQL instance and database configurations. So it's great idea to separate the database instances, so having 2 separate instances for the operational and data warehouse databases. It's a good idea to configure a minimum amount of memory for your database instances and also reserve some memory for the host operating system. What's also very important is to have configured the proper NTFS allocation size for all your SQL disks. And again, options like SQL max degree of parallelism or cost threshold for parallelism, as well as enable optimize for ad hoc workloads options, configuring those is very nice idea in order to boost the performance of your management group. The second part we will cover are the SQL databases themselves. What's important here is to precise them and also the log files. There are certain rules for this. Also take into account autogrow setting. You need to configure autogrow for your databases except for the operational database. There, configuring autogrow can cost you really performance and can be also a source of troubles, so please don't do this. What's important is to create as many files as needed to maximize disk bandwidth, especially important for the TempDBs, and also make each of the files the same size. If possible, always put your TempDBs on fast storage or SSDs, and also separate data files from log files. Setting a proper recovery model for your database is very, very important also. Recommended is actually a simple recovery model, but if you have SQL always on, then you need to jump to a full recovery model. Configuring a proper database maintenance is really of essence. So rebuilding indexes, checking the database, that's very, very important. And later in the presentation, you will find the link where you can download a plan for all those jobs. And I will make a short demo on how you can configure those settings and also how you can create all the maintenance jobs you need for your SCOM. Jumping to my server. So this is my server and it runs in Azure. I have two databases on this server. This is the operational database and I have also the SCOM data warehouse. The first thing you will notice here, I have two instances. So separating database instances is very important. So each database has its own TempDBs. And as you see here, my operational manager database has its own TempDB. I have already set or preset the server power plan to high performance on this server, and I would like to show you the SQL instance memory configuration we mentioned. So when we navigate to the settings of the instance and you go to memory, you'll see here that I have allocated a minimum amount of memory and also a maximum amount of memory so that I can keep track of the memory that my server uses. And this is of course the case for the data warehouse. The next thing I would like to show you is how I have configured my disks. What you notice here is that I have separate disks for the separate type of files. So one disk for data files, one disk for TempDBs, and one disk for log files. The reason for this is because I have chosen here to configure the TempDBs on faster storage, meaning SSDs, so that I can really get the maximum of the performance. So jumping back to PowerShell console, and what you see here is actually the allocation unit size of all the disks we just saw. And what you see here is this number. Those are 64 kilobytes, and this is the recommendation for SQL disks. So please ensure you format your SQL disks, data disks, and log disks properly. The next thing we shortly mentioned is actually creating all the maintenance jobs. For this purpose, I have downloaded, let me show you this, I have downloaded SQL query, and this SQL query you can find on the link we will see later. I'll open it. This is called Maintenance Solution SQL. I'll click on Open, and the SQL query will actually create all the jobs for me, and I will just need to select it. I need to execute it for my operational database, as you see here, and then I'll click on Execute. So you see command completed successfully. Let's jump to the jobs and see what jobs do we have here. So if you take a closer look, you'll see we have database backup jobs for user databases, for system databases. Very important, we have an index optimization job and also some additional jobs. So now what we would like to see is how the instance is configured. So we will check the options only for one of the instances, but you can of course do the same for both your instances if you have two of them. So as we already saw, the memory is configured properly. What's important here is the advanced configuration, and here we have options like optimize for ad hoc workloads, which is set to true, and this is the recommendation for SCOM. We have also the option cost threshold for parallelism with the value of 50. Just notice that the value of 50 is not a default value. So the default is actually 5, but I have increased this according to other recommendations. And the last thing we would like to cover here is actually the recovery model of the database. So I go to my operational database, I click on the properties, and then I'm going to check the options on the database. And here, what you will see here is that recovery model is set to simple. That is the recommendation for databases which are not part of SQL OSON availability group. And we are jumping back out, and I would like to show you now the next thing you will have to do as an assignment. This was actually the walkthrough I just presented you, and your assignment would be to set the Windows Server power plan on your SQL Server to high performance. You have to configure the minimum amount of memory on each instance. You have to reserve memory on each SQL instance, and also verify that the NTFS allocation size is properly configured for all the disks. The best way would be to use PowerShell, and please also check if the options SQL max degree of parallelism, cost threshold for parallelism, and optimize for ad hoc workloads are properly configured. And also what you have to do is to check your SQL database jobs. We will see how exactly. For those steps, you have additional 15 minutes, and to be easy for you to do this in those 15 minutes, I have prepared a so-called cheat sheet where you can really go and see how or where you can find the options, how the options are configured, and get additional information. What you will notice here is actually the last link, SQL Index and Statistics Maintenance. If you just look it up, Ola Hallengren, and download the SQL file there, then you can create all the SQL jobs you saw also in my demo. So guys, 15 minutes are running. Enjoy. We will see you again in a minute. Hello again, everyone. 15 minutes are up, and I hope you had the chance to configure all the SQL related options we just covered. And now let's further jump to session block 3, where we will discuss some infrastructure and application level optimizations. Now, what are those? The first thing we will start with are some registry keys that are optimizing the health service. And of course, Kevin Holman covers in his article, you see in the slide, also some other optimizations related to the general management server performance. So please go through the explanations in the article so that you really understand what the impact of changing those registry key is. And later, during the walkthrough, you will see how I will handle the optimizations. The next article is about disabling workflows which you might not need, like collecting agent health states or management group active alert counts. There are also two discoveries that are covered in this article: collect agent configurations and collect agent versions. Please make sure you have checked what those actually do and disable them in case you think those are not needed in your environment. The next point is very important in case you have a SCOM 2012 R2 or SCOM 2016 installation, and covers some health service memory threshold optimizations. If you don't increase the thresholds mentioned in the article, you might end in a situation where the Microsoft monitoring agent restarts because the health service has allocated more memory than it's allowed to. And in case you have a SCOM 2019 installation, you can skip the optimizations as the thresholds have already been increased to the recommended values. It is still a good idea to enable alert generation for the mentioned rules so that you're able to track the memory allocation in your agents. Next, we will cover some over collection of events which needs to be turned off. So turning off the over collection of events is a great idea because there are certainly many events which are collected in large numbers and which you most probably don't need. This article describes how to find those and also covers how to disable those. We will also go through this process in a couple of minutes. A large amount of data is being inserted into the operations database from agents about monitors that are constantly changing state. And those frequent state changes need to be really disabled or identified and disabled. Often you might have no idea that this is happening to you because the alerts disappear so fast that you can never see them. And this particular article explains in great detail how to find out which are the monitors which are flip-flopping and how to disable those. Now, let's go through the optimizations we just covered. I will show you only part of the stuff and would like you to take over the rest. And I have also prepared a small cheat sheet, exactly as in the previous exercise. So let's jump to my management server, and we mentioned those registry tweaks. So what Kevin Holman does in his article is not only explaining all the settings you need to disable or to optimize, but he also gives a reference to all the registry keys. So you can simply copy those like I will do here, and I'll just open a command prompt as an administrator and make sure all the settings are pasted there. So as you see, this goes pretty quickly, and now you have the recommended settings in your registry. Next, we will jump to finding out how to stop over collection of events. And what you see here is the SQL query which Kevin Holman gives in his article, which will help you identify the most collected events in your environment. As you see here, in my environment, the most collected events are the events from the SDK service. And you see also the ID here. So what we can do with this is identify which rule collects the event and then disable the rule in case I don't need the event. So be sure that you first identify the event, be sure to analyze it and make a decision if you really need it, or you can disable it. In my case, I really don't need the collection of those SDK related events. So what I'm going to do now in SCOM is to create a view under my workspace here. And this view I will call, let's say, new, and then event view, and this will be the SDK related event. So now I need to specify an event number here, and how to identify the event. That will be easy, and this will be actually the result of your SQL query. In my case, this is the event 26328. So let's enter it. So now when I confirm with OK, you will see that all the events my SCOM has gathered appear here. And the cool thing about this is here in the event details sections, you can easily identify the alert generating rule which collects this event, and you can simply click on it and also make an override to disable it. So if you have an event which you don't need, it will be really a good idea to disable all the events. And now, without further ado, let's change to the assignment. So your assignment would be to do the management server registry tweaks, to disable all the resource intensive workloads as described in the article, and also to optimize your health service memory thresholds in case you're running 2012 R2 SCOM or the 2016 version. You have to identify the events which are collected in your environment in large numbers using the SQL query, and then find out which rules are collecting those events, and then disable those rules, and also cover the frequent state changes and get them under control. So for this purpose, you have 15 minutes, and as already mentioned, I have prepared a small cheat sheet which I will leave on the screen, and those are the tasks you have and how to achieve those. Simply look up the name of the task and the name Kevin Holman so that you find the article, go through the steps. They are simple steps, they do not require much time, so you should be able to do them in 15 minutes. Thank you, and talk to you again in 15 minutes. Hello again, everyone. This was the last exercise for today's workshop. And now let's do a quick summary, a quick recap of all the things we have learned today, all the important stuff. I have divided this recap in 3 blocks, logically, like the exercises we had today. And the key takeaways from this first block would be to gather as much information as possible during the planning phase. When you plan your management group, having all the details in advance plays a key role. So you need to study well the environment, its topology, and all the specifics, because this will help you make a decision in regards to all the important stuff like number of management groups, number of servers in each management group, etc., etc. You should always pay attention to the business aspect. So how your IT is organized, how your organization structure looks like, because this will also have an effect on how your management group is designed. You should always plan cautiously for high availability if this is required, of course, and you should always prepare well before starting the actual implementation. So creating all the service accounts in advance, giving all the permissions, preparing all the SQL databases, and sizing plays also a key role here. As we already saw, you need to size your environment properly and also plan for potential growth. So those would be the key takeaways from the first block. And if we shortly jump to the key takeaways for the second block. So here we talked about SQL Server related optimizations and following some best practices. So you should always invest time in optimizing and fine-tuning your SQL backend. We understood how important this is and why we should always pay attention to all the storage related configurations, as the storage is one of the key components for the DB performance. We should also pay attention to how the SCOM related options are configured, or the SQL related options for SCOM, and those be maxed up, cost threshold for parallelism, optimized for ad hoc workloads. Those can dramatically improve the performance of your management group. Of course, sizing and configuring your databases properly, and those, of course, log files, plays a key role. You should do this properly and invest time for this. And you should not forget creating all the SQL maintenance jobs, because they will help you increase the performance of your database. The next thing would be the session block 3 and the key takeaways from session block 3. There we talked about infrastructure and application level optimizations. So you should always take care of your management servers. You should always update them. You should configure the registry keys mentioned by Kevin Holman in his great article. A good advice would be not to import unnecessary management packs. So if you have management packs that are not used or not required in your environment, it's a good idea to delete them. Additional management packs, they just introduce additional workflows like discoveries, which in case they're not needed, they should be, of course, deleted. You should always disable the workflows that can cost you performance. Of course, those should be workflows which you don't need. And the same applies also for data collection. Events which are not required or do not carry useful information for you should be disabled and should not be collected. All the key takeaways, all the information we covered today is summarized in this article I wrote back a year ago. So you can open it and you can find the reference to all the links there. And I hope you find it very useful. I'm going to be available for you for questions, and I would like to now thank you for attending my session and taking your time to follow all the stuff here. Let's also say thanks to Squared Up and Cookdown. They made made it possible that we are together today and do all the great stuff. Thank you guys. Have a great day ahead.